Okay, welcome to this next session where we will look at arrays in C. So arrays are a common type of a data structure which is there in many programming languages. So we look at how an array is represented, how you can assign arrays, and how do you manipulate multiple array elements or access each element. We'll also look at things like variable length arrays, which are a modern C language feature. In some conditions, you can use a variable length array, and then multi-dimensional arrays actually. Okay. So essentially, an array in most programming languages, it's a collection of data items of the same type. Right? Okay. Basically, say you want to kind of deal with a good example would be you want to store, say, the marks of all the students in a class, right? So maybe mark is a floating point value, so you want to store the marks of all the students. Say 40 students are there. I want to store them together and do some common processing for all of them, right? Then a very natural data type or a data structure for that is called an array. Okay. So and you can once you declare an array, you can actually access each element of the array, and that is by using what is called as index or position in the array. Index is nothing but a position of item in an array. In C language, the indices start from 0. So in many modern languages, the indices start from 0 and go till, if say there's an array with n elements, the first index will be 0, the last index is n minus 1. Okay, so n minus 1 is the final element, and you can read and write each element of the array independently. And important functionality from a what to say, the architecture of how it is implemented, right? It's an important behavior of an array is that the elements are all allocated continuously in memory. Like if I declare an array with say 100 elements of say type character, it needs 100 bytes of storage, and it'll all be contiguous in memory actually. So that's an important behavior of how arrays stored in the memory, and that fact will be used when we use pointers to access elements of an array. So arrays are always stored in consecutive memory locations, and that's why sometimes they're called as a linear data structure. So it's a continuous storage, and the first element will have that index 0, the last element will have n minus 1, so it'll keep going in sequence actually. Okay, so if you have 10 element array, the 10 elements will be in contiguous locations in memory. If it's a 10 integers, the first element will take 4 bytes, the next 4 bytes will be the second element, and so on. If it's just characters, one byte each, or if it's like bigger, I mean, you will later see arrays of structures and so on. Everywhere it will be contiguous actually. Okay? That's an important feature of an array. So that's what we need to remember. The important thing to remember is it's a homogeneous type. All elements of the same type actually. And index you have to remember. Index starts from 0 and it goes till n minus 1. N element array will have index from 0 to n minus 1. You can read and write each element independently, and from a storage perspective, they are stored in consecutive locations. That's an important thing actually to remember. And we also just talked about it, right? So why do we need arrays? It's convenient to store group things, in a single name and in contiguous locations, so you can process them faster. For example, I want to take the average of all the marks. Let's assume I didn't have an array, right? So assume I have a variable for each student. I call it say student 1, student 2, student 3, like that. Okay. So I have 40 students, I have 40 variables, right? And I want to initialize the mark of each student. So I'll have to write code like S1 equal to some mark, S2 is like this, so on, till S40 I'll have to write. Then if I want to compute the average, I'll have to write some long statement, something like sum is equal to S1 plus S2 plus so on till S40. Okay. And finally, I can say average is sum divided by 40, like the second, right? So it's going to be a very lot of code, first of all. And if it is 40, it is okay. If it is some 200 students in a class, it's going to be like much more complicated. So naturally, this becomes very painful to write a program just using different variable name for each of the student, right? Instead, if there is a construct which allows me to refer to all the students together with just using, say, maybe a roll number or something as an index to that, then I can write this same code in a much more efficient fashion, right? So that is where arrays come in. So you can see the problem, right? If I want to do things like this, which is very common. If you have 1,000 employees in an organization, I want to kind of take their average salary. I can't, if I have one variable name for each employee, it's going to be a nightmare to write a program. And if 10 more employees join, I have to modify the code and so on, right? It becomes very painful. So that is where it's always convenient if you can have a single variable name, where under which you can store multiple items, each corresponding to maybe a different student or a different employee or anything else for that matter, and have a way of accessing each one by one using a construct. That is where arrays come in. And the moment you have that, you'll also see arrays and loops go hand in hand. When we look at the definition, you'll also see that once you have an array of say 100 elements, you can write a loop to do that 100 times and access each element in that array and do whatever operation you want. So arrays and loops go hand in hand, and so that's an important reason why we need arrays actually, right? Without arrays, even the simple program, things like calculating an average for 100 students in a class can be very, very long and cumbersome to write and maintain and so on actually. Okay. So let's now go to the syntax of how we declare an array in C and how we use it and so on. Okay. So array representation I already talked about. It's a set of homogeneous. Homogeneous means same type, and it's finite because arrays have a typical size. You have to declare the size of an array before you use it. So you declare I want 10 elements or 100 elements or whatever, either statically at compile time or runtime in the variable length array case. And it is ordered. They are ordered because they go from sequence 0, 1, 2, and so on. And how do you declare an array? This is the syntax of an array declaration. Okay. So basically, you give a type name, then a variable name, and within square brackets the size of what you want to, how many elements you want to declare. So this declares an 100 element array by name A, which contains integers actually. Okay, so this is 100 element integer array. A is a 100 element integer array. Is that clear? So the type comes first, the name, then in square brackets the size, and it's a single dimension array because there's only one dimension here actually. And typically like memory allocation, right? So how many bytes will that occupy? How much space is occupied by an array, right? So it is, for example, in the previous case we had declared a 100 element array of type integer. Assume a single int takes say 4 bytes, right, on this machine. Then for 100 elements, how much do you need? 4 into 100, you will need 400 bytes of storage for this single array, integer array of size 100. You will need 400 bytes of storage actually. Okay, so basically you can easily calculate the amount of space that an array takes by doing this. Basically 5 into size of int. That's how you get the size of the array. And indexing is nothing but accessing each element in the array. Positions, indices start from 0. Okay, indices start from 0, and you can access each element by increasing the index. And how do you initialize an array? There are different ways of initializing arrays. That's good to understand that. So first thing is, you can initialize an array at declaration itself. This is called explicit initialization. So the syntax for an explicit initialization is like this. So you can say int numbers, and see this interesting thing here. We are just putting the square brackets. We are not telling the size here because immediately I'm initializing it here. So the way to do it is you put an equal to and you put this starting curly braces and all the elements separated by comma, then closing curly brace and a semicolon. Now when compiler sees this, it will automatically know that this is a 1, 2, 3, 5 element integer array. So this 5 is automatically decided by the compiler because you're initializing it explicitly. Otherwise the compiler will not know how much space to allocate for it, right? Okay, so if you are not putting any number between these square brackets, then you have to typically initialize it immediately. In this case, compiler does that job for us. It will calculate, okay, you're given 5 elements, so it will allocate a 5 element array here. Okay, if you don't do that, the compiler will say, no, this is not valid actually. Another thing is partial initialization. Partial initialization, what we do here, we declare the size to be 5. Okay, the compiler will allocate space for 5 integers for this array, and I'm only initializing the first 2 elements. Because I have told 5 here, compiler knows it's a 5 element array, but the first 2 elements are initialized. Only the index 0 and index 1 are initialized. The remaining will be set to 0. So the language guarantees that when you declare something like this with partial initialization, the remaining elements are set to 0. So if you have to see it graphically, like, assuming this is the space for the integers, this is index 0, 1, 2, 3, and 4. Okay, when I declare like this, say this is the array numbers. Okay, some addresses will be there. I'm not writing the addresses. Obviously, some address will be there. If it's an integer, this will be address 4 and so on. This initialization will make this 1 and this 2, and automatically these will be made zeros actually. Okay, so totally you can say 20 bytes will be allocated. Compiler will allocate space for that, but only the first 2 indices are initialized in this case. Okay, so in this case, all the 5 would have been initialized actually. Okay, and then this is called designated initializers. So when you have the syntax like this, it means the first 2. But if you want to initialize specifically some indices, you can again do like this integer numbers 5. 5 things are allocated. But look at the syntax here. I'm saying within square bracket 2 is equal to 42. Within square bracket 4 equal to 10. So instead of these things, it would have actually only 2 and 4 will be initialized. If I had to draw it here. So indexes are like 0, 1, 2, 3, and 4. So index 2 will be initialized, which is 42, and index 4 will be initialized to 10. The rest will probably be 0. So these are just to know the syntax. Generally, you will not see these things used very commonly. But just for sake of completeness, we are covering it. Mostly, we will be generally initializing all the elements of an array, or we'll be just declaring the array, and we can actually write a loop to initialize the array. That's the most common thing. These kind of designated initializers are there. The language supports it, but usage, I would say, is very, very less actually. Not too many people use it because generally the use case for that is very rare. Mostly, you will either initialize everything here or declare the array and write a loop to initialize the array with some contents that we are interested in. Is this clear? So you can initialize here. The convenience here is you don't have to write the size here. Compiler does that job for us. Whereas here we declare the size, only initializing first 2 elements. Here we declare the size, declare and initialize specifically few elements that we are interested in actually. Okay. So these are the different forms of array initialization. The same thing would true if it is a double array or a character array or whatever, right? All are similar. I'm just showing an example with integers here. Okay. And next step is how do I access a particular element, right? To access a particular element, the syntax is you give the name of the array variable, and then in square bracket you give the index actually. Okay. So for example, let's say I have declared this array ARR1 to be of 100 integers long. Okay. And I have declared some variables A and B, simple integer variables, scalar variables. I am declaring this variable A to be 5, B to be 6, and then I'm trying to initialize some of the variables. I'm using those array indices to initialize and do some computations. How do I do it? If I want to say initialize the first location with the value 23, I write like this: array1 is the name of the array. Then within square brackets, I give the index. I give the index here, and I'm assigning a value. So here, basically, if I have to draw this array here, like so, it's a 100 element array. Okay, so what are the indices going to be? Indices are going from 0 till, what is the last index? 99, right? Which is size of 100. So 0 to 99 will give you 100 elements. Each is an integer. Okay, and when after we do this operation, ARR1 of 0 equal to 23, see this location in the array will get 23. Are you understanding? Okay, so the syntax is array name, left square bracket, the index, and close the with the right square bracket. So similarly, we are doing a equal to ARR1 of 12. Okay, assume ARR1 of 12, 12 is here. Assume it had some value 25 or something like that, right? After executing the statement, what will happen? ARR1 of 12, that whatever is there in that location, that will get stored in A. So suppose variable A is here, now that will get the value 25. So this syntax can be used either on the left hand side or right hand side. Right hand side means I'm reading it. When it comes on the left hand side, I'm storing it to the array. Is that clear? So you can use in computations also. Any expression, you can have an array name with an index. It is just like using any other variable. Once you give an array name and an index, in this case, you are nothing but referencing to the value which is stored in that element or that position in the array, and you can use it in all computations. Say, look at this. I'm saying ARR1 of 99 is equal to A plus ARR1 of 90. So basically, ARR1 of 99, this location will get the value which is nothing but A plus say 90 was here, some value X was there in this, say 22 or something was there. 22 plus what was there in A plus 25 will get stored in this location 99. Is that clear? So once you declare an array, array elements can be accessed by using the array name and within square brackets, the index of the array. Okay, and it is invalid to access indices which are not part of the array. Some compilers will give you a warning. Some compilers can even be silent, right? So you should never access beyond the array because you'll get undefined values. Compilers sometimes may warn you, sometimes they may not even warn you. So it depends on the compiler. But as a programmer, you have to make sure that you are only, see, sometimes you may write a loop, right? A common mistake in C is you write a loop to access all the elements. We'll see that example soon. You would have gone beyond the end of the array. Sometimes, you will get an error if the compiler supports it, or sometimes silently you will be accessing some content which is not actually legally part of the array. Actually, okay. So you have to be aware of what is the array boundary and use it properly. The biggest index can be only, if an array of n elements, your index should not be more than n minus 1. If it becomes n also, it's an error because you have gone one element beyond the end of the array. Is that clear? So we'll see some examples of making those mistakes. But so now let's, as I told you, right, it's very convenient to access elements of an array using a loop actually. Okay, so it's the most common way to access an array using loop. So in this example, we have declared an array called nums with 20 elements. Okay, and I want to initialize that array with some values starting from 100, 100, 101 like that. So I'm just writing a loop for that. So I'm having another variable called I, which I'm using like a loop index. And I'm writing a for loop here. I'm starting with I equal to 0. Then I'm saying I less than 20, I plus plus. What am I doing? I'm saying nums of I is equal to 100 plus I. Let's see how this loop works. Let's say this is our nums array. This is our nums array here. Okay. Index starts from 0. What is the last index? It should be 19, right? 19 is the last index because there are only from 20 elements in this array, right? And I have my variable I here. I'm starting with I is equal to 0. Okay. And what am I doing? First iteration of I'm entering I equal to 0, I is less than 20, the loop is entered. Okay, just follow what I'm doing here. So in the for loop, what happens? Expression 1, this expression 1 gets executed first. So I gets the value 0 because of that. Then I check the condition. I less than 20. Is 0 less than 20? Yes, 0 less than 20. So the loop is entered. What is the first statement in the loop? Nums of I. Nums of I is this array with I is 0. So this is the destination. It is on the left hand side of your assignment statement here. So this is going to be the destination where something is going to be stored. What is going to be stored? What is the right hand side? It's an expression. The expression will be evaluated. So 100 plus I, right? So I is having the value 0. So 100 plus I is 100. So the value 100 is now going to get stored in this location. Is that clear? Now we come, the next statement is nothing but the end of the loop. So the moment you come to the end of the loop in a for loop, what happens? Expression 3 will be executed. So which is I plus plus. So I is now getting the value 1, right? And then the check will happen. 1 is less than 20. Yes, 1 is less than 20. So you come inside the loop. Okay. So now nums of 1, nums of I is 1. So nums of 1, which means this is my destination. And what is going to get stored there? 100 plus I. I is 1. So it is going to be 101. So the value 101 will be stored at index nums of 1. And it loop goes on like this till 19. So it will get the value 119 here. Okay. And after that, I plus plus I will become 20. So when I becomes 20, this condition I less than 20 is false. So it will come out of the loop and the function ends there. So this is a simple loop to initialize this array with values from 100 to 119 sequential values. This is a way of initializing a loop. Instead of doing an explicit initialization at the declaration time, we just declared the array here and initialize the array using a loop. So this is a common thing that you will see where you use a loop to initialize an array, right? This is different from the previous case where we declared and initialized at the same time. Here we did the declaration separately and we initialized it separately. Is that clear? And important things to remember is you have to make sure your termination condition is proper, right? It should be I less than 20. If you are given I less than or equal to 20, it's an error. Because why? Then you will run the loop for nums of 20. Nums of 20 is beyond the end of that. So they always remember this 0 to n minus 1. That is the thing. So the standard thing in C is I less than n. If n is your loop size, I less than n is a safe thing to do because the loop will exit when I becomes n. And the last thing would have been n minus 1, which is the last element in the array, right? So once you keep doing a lot of C programming, this will become natural. The moment you declare an array of 100, you'll automatically write I less than 100 without even thinking, right? It becomes second nature to you actually. Okay? So what is called, I mean, you'll hear these terms when you program, right? Traversing an array. Traversing an array is nothing but accessing all the elements of the array and doing some processing, right? So we can again simply write a loop to do that. Let's say in this case, we're taking a simple example. We have declared an array nums, which is storing 5 integers, okay? We are initializing it here automatically. I just want to write a loop to print all the elements of the array, right? I can write a simple loop like this, again a for loop, declare a variable I initialize it to 0. And I have to run, I know 1, 2, 3, 4, 5 elements are there. So I'll have to loop should be I less than 5 here, I plus plus, and I'm just printing a message at index. I'm giving a format specifier here. Value is another format specifier. Since there are 2% specifiers here, how many arguments should I have this printf? I should have 2 arguments. So this whole thing is a format specifier string, comma. First I'm printing I, then I'm printing nums of I, right? So when I run this loop, what will happen? I will just say 0, 10. In the next line, I will say 1, 11, 2, 12, 3, 13, 4, 14. When I becomes, this is I, right? And this is nums of I. So that is what is getting printed on your screen here. Is that clear? So traversing an array is nothing but going through all the elements of the array and doing some processing. In this case, we just are printing it. But you may, for example, want to add everything or whatever, right? So when you hear the term traversing, just understand it just means going to every element in the array in sequence, okay? So that's what is called traversal, array traversal. And just to see some simple examples with arrays, right? One of the common things you may want to do is to search all the elements for search for a particular value in an array and print a message, right? So again, you'll do the same thing, right? In this case, we have declared some 2 variables I val, and we declared an array of 10 integers. We are also initializing it here. And assume I'm reading a value from the user. Basically, there's a small program to read a value from the user and to check whether that value is present in the array. If it is present, we are printing all the indices where it is present. Okay. So how do I write a program? Again, I have used this I as a loop variable. So I have to run the loop. The array has 10 elements, so I run the loop 10 times. Okay. Then I increment the array index every time in the loop. What do I check in the loop? I just check if that index in the array is matching the value that the user typed. Actually, okay, user is giving an input. I'm just checking whether the value is matching any of the positions in the array. So every iteration in the loop, one index position is checked, and if it is matching, this if condition becomes true, I print a message saying value, I print the value again, found at index, I print the value I here. Are you seeing this? So there's a simple loop to print all the positions in an array where a given value is found actually. It's a simple use of an array and to search through an array and print a value. Okay, so just an example for that. Another thing which is a feature in modern C language. See, normally we have so far seen the array index is specified by a constant. Okay, so there's one case where you can specify that using a variable, and that is only as a local variable. See, what are local variables? Local variables are variables which are declared inside a function. Okay, in local variables, modern C language supports what is called as a variable length array, which means when I say variable length, the length can be determined at runtime. Okay, so for example, I can, if this is a function, right, I'm putting it, that's why I'm showing this curly braces. Any declaration which comes inside a curly brace automatically means it's a local variable. So I could have had a variable say a, and I'm actually reading a value from the user for that value a, and then I'm giving a declaration here int DARR of size a. Instead of giving a constant, I'm giving a variable here. Okay, if I type, the user type 10, this will become a will become 10. So the compiler would have allocated space for the code would have generated to make sure 10 integer space is allocated here. If I had say for example type 100, then it would be a 100 element integer array declared there. The reason this works in the C language, it's possible to support this is because in C language all the local variables are stored in a space called the stack actually, and stack keeps growing with the program. When a function is called, some stack space is allocated, and if you are declaring something like this dynamically, the C program, the code generation will automatically adjust the stack size. The stack pointer will be adjusted based on what you're allocating here. So it's possible to do at runtime. So only in the case of a local variable, you can have a dynamic array. Whereas if for example, you have a global variable, there is no way to use this. You cannot, if the same statement was given in say ARR and N, and if you have declared a variable int N something here, right? This is not valid. You cannot give a variable name as an array declaration type, size specifier for a global variable. But it is possible in a local variable, and that's the only reason it's possible is because space is allocated on the stack for local variables, and the C compiler can generate code to adjust the stack size based on these declarations and what values are found at runtime when this program runs actually. Okay, so this is convenient when you want to do some operations. So it's a feature in the modern C language where you can have a variable length array which is determined at runtime. The user can tell you how many elements he wants to operate upon or store or whatever. You can declare an array of that size, finish the operation, and once when the function comes out, that space is automatically freed up actually, right? So variable length arrays are possible in C, and you can actually, instead of giving a constant for the array declaration size specification, you can give a variable name there. Only thing you have to make sure that variable is initialized before you use it. Okay, suppose I declared something like, say, one common mistake you can do is declare int a and then immediately say int ARR of a. This is very dangerous, right? Because here you have just declared the variable a, you are not initialized it. So some garbage value will be there. And moment you say this, the compiler, the runtime code will now try to allocate an array of size a. If a was, the garbage value was a very large number, right? It's a stream of bits only, right? If it was all ones, for example, that's a huge number. And you will normally get some failure here because there may not be so much space available on the stack to allocate such a big array. So the program will fail with some segmentation fault or something if you do something like this. It again, by chance, it depends on what value, garbage value is there in A. If it is 0, nothing, the array would not have even been declared. If it is a small number, it would work. But if it's a huge value, you will see some failures, which tells that it can't allocate that much size of an array, because stack typically will be limited size. Okay, that's one thing you have to be aware. Variable length arrays, because it is limited by the amount of size allocated for a stack in that environment. So if you try to allocate a very large array there, you may get a failure saying stack space not sufficient or whatever. So that's the thing that I already talked about. It's only possible as a local variable. You cannot declare it in global scope. It can be only local variables, and it works because it's allocated in the stack space. And we have to be careful about the size of the array we declare, because the default stack size may not be sufficient if you're trying to allocate a very large array. Okay, that's something you have to be aware as a programmer. It's a nice feature, but you have to know that what you are asking for, the size is not something very large that the stack cannot support. Actually, the last thing in arrays that you want to look about is what is called two-dimensional, or in general n-dimensional arrays. Two-dimensional arrays we commonly use, for example, to store a matrix, right? You have seen matrices in mathematics, right? It's a two-dimensional structure. So you can store a matrix by a two-dimensional array. So in C, a two-dimensional array will have two square brackets to specify the size, actually, right? So if I want to declare a two-dimensional integer array, I'll just say a of some, say, 5, 3. Basically, that means the first dimension is 5, the second dimension is 3, actually. And the total size occupied by this will be 5 into 3 into to size of a int. Size of an int is, say, 4 bytes. The total space allocated will be 5 into 3, 15 into 4, 60 bytes, actually. Because that is what a two-dimensional thing means, right? A matrix will have, say, 5 rows and 3 columns. Like you may have, and the indices will again be from 0, 1, 2, 3, and 4. And say you have columns from going from 0, 1, and 2. Okay? So this is like a two-dimensional structure. Typically, a matrix can be represented like this. So, or sometimes you are developing a game, right? You have a Sudoku board. So it's a 3x3 or a 9x9 array where you store all the numbers, or you're designing a crossword game. So again, it's a matrix of characters, right? You can probably represent your crossword puzzle as like a matrix of maybe 10 by 10, depending on the size of your matrix, right? And each element can either have a character or it's a grayed out. In a crossword, some cells are grayed out. You can have some notation to represent it, right? So two-dimensional structures are quite common, but in general, C, you can support n dimensions. If you're operating, say, a 3D space or something like that, you need 3 dimensions, right? If you're developing a program dealing with graphics in 3 dimensions, right, you'll have probably 3 coordinates, x, y, and z, which can be 3 dimensions of your array. So in general, C supports n dimensions, actually. So that's something to understand. And this is how you declare. I talked about already. So you type, as usual, the data type comes first, then the name and all the dimensions in 1 by 1. Dimension 1, 2, and it can be n dimensions. So you can do like this, Sudoku board or crossword or whatever. Right? So these are all examples of two-dimensional arrays that you want to use. Similarly, you can also initialize a two-dimensional array at declaration time. Suppose I want to declare my matrix here itself, right? 3x4 matrix. This is the way you do it. So earlier we just saw for a single dimensional array 1 curly brace, right? So it's just an extension. So this is the first row, second row, and this is the third row. So 3 rows and 4 columns, right? So first row contains 4 columns, 1, 4, 5, 2, 2, 1, 2, 3, and so on. So this represents some two-dimensional structure like this. So this is your matrix. You can initialize it like this, right? So basically, you will see nested curly braces. So one curly brace for one row at a time, and each curly brace is also separated by commas. Understanding? So it's quite simple once you understand. So this represents a 3x4 matrix, 3 rows and 4 columns. So this is, for example, a tic-tac-toe game that you want to develop, right? Tic-tac-toe game. You want to represent a 3 by 3 cell, and you want to initially put a E. I initialize it, E means it's empty. Okay, the first player plays, he may put a, second player puts, he may store a B. If there is E there, I initialize it with all E's, which means my board is empty. Just as an example of how you develop, a simple data structure for a tic-tac-toe game, you can have a 3x3 character array to store either E as for empty or something else actually. So this is again how you do a 2D element at declaration time, and you can have more examples. We're not going into too much detail for two-dimensional here. Typically, if you're doing mathematical programs, that becomes important. Probably in embedded systems, you may still deal with two-dimensional, but you're not going to depth. The same way you access, actually, if you want to refer to an element, if it's a two-dimensional array, if I say a of 1, 2, it refers to that first row, second element actually. So a of 0, 0 is basically your first element, and a of n minus 1, m minus 1, assuming n and m are the dimensions, this is the last element in the two-dimensional array. Okay. And if you want to initialize a two-dimensional array, you can use a nested loop, right? Just like you initialize a single-dimensional array, you can use a nested loop to initialize a two-dimensional array. Okay, and you can have multi-dimensional arrays. N dimensions are also possible. So to summarize, arrays are nothing but data structure where you store similar elements under the same name. You use an index. The index starts from 0, ends with n minus 1 if n is the dimension. And loops or natural constructs to go through elements of an array. Going through all the elements of an array is called a traversal. You can go every element and then print them. And you can define multi-dimensional arrays when you want to do matrix operations, or if you want to, in embedded systems, you may have things like an LED array or an LCD array. If you want to address, for example, all the pixels on the screen, you can represent it as a two-dimensional array and then go and write some pixel value for each location in the array, right? Now we will just look at a few running examples to look at how to write arrays and print or traverse and stuff like that. Let's do a quick couple of examples of that. Let's start with simple, maybe a character array, right? I can declare a character array C1, and character array can be initialized like this. Let's declare all the vowels in this array, for example. Okay, so I declare a character array here, right? Now I want to write a loop to print all the elements in the character array. So I'll just also introduce a couple of concepts. Let's see today, in this case, I have type 5, it's easy to count. Assume there are many characters, right? I don't want to sit and count. How do I find the size of an array? This is where the size of operator that we saw comes into play, right? Size of operator, what does it return? It returns the size in bytes. Okay, so we can do something like this. We can say int n is equal to, we can just say size of C1 divided by size of char. Why am I doing this? I want to get the number of elements in that array, right? If a character is because it's 1 byte, dividing by size of char will divide by 1, it's not an issue. But if suppose it was an integer, if it was 10 integers were there in that array, the size of would have given me 40. But I'm interested in the number of elements, right? So if I divide it by the size of one integer, I get the number of elements, right? So now I have got n properly. Let's print n and see, whether we have got the expected value. Okay, so it'll help us to debug if something is wrong. Assuming n is correct, now I can write a simple loop to print every element of this character array. Okay, let's start with int. I can write a simple for loop. Let's say I equal to 0, and let's declare I here. Let's say int I. We're not initialize it there. I equal to 0, I less than n, because if n is the size, the last index should be n minus 1, right? If n gets the value 5 here, I should go from 0, 1, 2, 3, 4. Okay, then I plus plus. Then all I'm doing is going to print that character here with a space in between. Okay, how do I access each character? The name of the array is C1 square bracket. I give the index. I'm going to use I as the index. That's why I'm changing I from 0 till n minus 1. So C1 within square bracket I. Is that clear what I'm doing here? So I just declared array. I'm just using this construct to find the size of the array because I don't want to sit and count here. So there's a good use of size of here. And I'm going to try and print all the elements of the array in the sequence. Let's see whether any errors, and we'll correct it if some errors are there. Okay. It didn't print anything. What did I miss? I forgot to put C here. Okay, that's why nothing got printed. I missed typing C here. So nothing got printed. But can you see it printed properly? But it's not looking nice because there's n equal to 5. I didn't put a new line character there. So it's the next character is getting printed here. Let's correct that. It's always good to put a new line after every printf statement so they don't get jumbled up. Now let's run the program. Can you see? It's printing A, E, I, O, U. It's printing a space because in the format specifier there's a space here. Okay, that's important to understand, right? Format, whatever is there, anything other than that percentage, that special thing, it'll get printed as it is. If I remove the space, you'll see it'll get printed contiguously. Is that clear? So we use the size of operator to do this. Instead of character, it could have been, say, a double array, for example, right? Could have done the same thing. Let's declare a double array like this. Okay. Now, same thing. The same construct I use to find the number of double elements here, because double actually is 8 bytes. So if this, the size of thing would have become, 4 into 8, 32 bytes would be the size, but I want to know there are only 4 double elements. So I take size of D. Size of D will give me, in this case, 4 into 8, 32. Size of double will give me 8. 32 divided by 8 will be 4. That is the number of double elements in this array. So that is now n, and I have to print using percentage LF. The name of the array is D, so I put D of I. So let's see how it prints now. Let's give some spaces in between because numbers are going to get printed. Okay, can you see? So it works fine. 3.14, 1.23. So in printf, it will always print 6 decimal characters by default. You can change it by giving some additional format specifiers here. So this is how you use array to print. You declare an array and you're going to print all the elements in the array, right? So we are going through every element of the array and we are printing it here. Now it could have been integer also, it could have been anything. In all the cases, it will be the same thing, right? If it was integers, we'll just modify the code to be I'll just say int here. Instead of percentage LF, I can say percentage D, and it should again print the same thing. Okay, forgetting. So this is how you do a single dimensional array. You traverse the array and you print elements. Let's say I make a mistake. Instead of saying less than n, I say less than or equal to n, right? I don't know whether this compiler will give a warning or it will print some garbage. One of the two things will happen. You can see some unexpected value got printed. That is because you have gone beyond the range of the array. Okay, the way the compiler would have generated code, these are things as an embedded programmer it's good to understand. What happens is code generation, when a compiler generated code, it would have generated some the first 4 addresses are valid. But when you say d of n, it would have generated an address which is just beyond the end of the array. So when you say d of n, there is an address, so some value is getting fetched, but that is not something that we have assigned properly. So some garbage value is getting printed. Okay, so when you exceed the array bounds, you will see some garbage value getting printed. There are some compilers which add some code to check the array boundaries and all that, but that adds cost. So in a C language, the general philosophy is okay, programmer knows what he's doing, so they don't unnecessarily add checks. But modern some compilers give you ways to inject some code to do some array boundary checks and all that. But normally it is not done. So the program will keep running and you'll see some garbage values actually. If I had given instead of n, if I had given 10, sometimes you may get a segmentation fault also. If I'm printing 10, it's printing say all kinds of garbage values, and each time it will be different, right? But sometimes if you run it infinitely, at some stage you may hit some invalid address and you'll get an error. But these are things to be careful about, right? So if you are declared an array, you have to make sure that this is properly bounded so that you don't print or you don't go and access beyond the array boundary. Actually, okay, that's something to remember. And so similarly, you could have accessed a two-dimensional array also. Like for example, if you have declared say a two-dimensional array, let's declare something three. To declare something like this. Okay, so I declared a two-dimensional array. Okay, let's not do all this now. We'll try to print the elements of this matrix. This is a matrix, assume it's a matrix. I want to print the elements of this matrix. Let's take two indices. Okay, so the first index is going to be the row index. I'll keep I for the row index. So row is going from 0 to 0, 1, 2, right? There are three rows in this matrix. So 0 to that. Second, the inner loop will use j, and I'm going to run from 0 to 1 because that is the second index is only 2. Okay. And in inner loop, I'm just going to print that index element there, which is say m of I j. Okay. So this is how you access an element in a two-dimensional. You have to give both the dimensions. So the loop is going to be for initially first time will be I will be 0, j will be 0. So it will be 0, 0. Then the inner loop will run, right? It will go from 0, 0, 0, 1. Then when j becomes 2, this inner loop will terminate. Then I will get incremented. So it will become 1. So it will now the first row. So when it comes inside, it will become 1, 0, 1, 1. Then again the second loop is over. It will go away in here. I will become 2. Then it will enter the inner loop. It will become 2, 0, 2, 1 again. So the last row will get printed. And for convenience, what we'll do is after printing every row, let's print a new line so that we know one row has got printed here. Okay. So at the end of the inner loop, I'm going to put one printer so that I go to the next line. Is that clear? Let's see how this code is running. Hopefully things are correct. You see that 1, 2, 3, 4, 5, 6 got printed because that is what we are going through. Inner loop, the inner loop prints one row, finishes. Once the inner loop is over, I'm printing a new line. Then I gets incremented, it goes to the next row. Second row gets printed, then a new line, then the third row gets printed. Is that clear? How to access a two-dimensional array? It's quite simple once you understand. So it can be n dimensions and you can keep accessing it. And you can do things like matrix addition programs, matrix multiplication programs by declaring. It's quite easy. Once you understand the nested loop concept, all of that becomes quite simple to handle.